Hello, in this STR8CHEM session, we're going to talk about on how to construct the most plausible expanded octet Lewis structure for PCl5. Phosphorus, as you know, will be the central atom. And the reason for that is because phosphorus is more electropositive than chlorine, okay? Than chlorine. And that is because phosphorus is in group 15, whereas chlorine over here is in group 17. So when you go across the period 15, 16, 17, electronegativity increases. Therefore, phosphorus will be more electropositive, and that is the reason why phosphorus will be your central atom and chlorine will be your terminal atom. So phosphorus, since it is in group 15, you have 5 valence electron, okay, PCl5. And then you have chlorine atoms in group 17, so it has 7 valence electrons. In PCl5 over here, you have 1 phosphorus atom, you have 5, and then you have 5 chlorine atoms, so 7 times 5, that would be 35. So you're gonna have 40 valence electrons in total. So that will give you a 1 mark. Okay, moving on to step 2. We know that phosphorus will be the central atom. It has 5 valence electrons, so you're going to distribute that evenly like this. It looks like the Lewis dot symbol for nitrogen, but because phosphorus is situated on period 3, it has d orbital characteristics. Therefore, it will be able to form expanded octet. Okay, and then we have the chlorine atoms. Okay. Like this. So when you get that correctly drawn, you have 1 mark. Okay. So when you look at step 3, when you want to draw the bonding pair, okay, and you have 1 here. So the reason why phosphorus is able to form expanded octets is because we have to look at the SPDF notation. Phosphorus. Okay, so the proton number for phosphorus is 15. Therefore, the SPDF notation is 1s2, 2s2, 2p6, 3s2, 3p3. It's obvious that this is the outermost shell, signifying that phosphorus is on period 3. So when they are on the third period, they can have d orbital characteristic, and that's the reason why they can expand their octet. So I'm gonna take this one. I'm gonna draw the orbital diagram for the valence shell. So you have 3s and 3p, like this. Okay, so do remember, so when you are on the third period onwards, you would be able to have 3d orbital characteristic. Okay, so this electron right over there will be able to be excited to that empty 3d orbitals. Okay, so this electrons over here excited to this empty 3d orbitals, giving you 5 unpaired electrons. So now you have 5 unpaired electrons. So instead of having a lone pair over here, you can get that lone pair to turn into another 2 unpaired electrons to make 5 unpaired electrons, so that you can form 5 bonding pairs. Okay, so that means this unpaired over here and that unpaired over here will form a bonding pair. This unpaired and that unpaired can form a bonding pair, and this unpaired with that unpaired will form another bonding pair. Okay, so remember, this one just now, one of them has been excited to here, and now you have additional 2 unpaired electrons. So that unpaired with this unpaired will form a bonding pair. This unpaired and that unpaired will form another bonding pair. Okay, so you have 5 sigma bonds. Okay, so this is what you call as expanded octet, because you have more than 8 electrons on the central atom. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have more than 8 electrons surrounding the central atom. So that is what you call as expanded octet. So you get 1 mark for that one, for the correct structure, Lewis structure of your PCl5. Okay.